Good morning, everyone, and welcome to the session. So it's good to see everyone after the party. How many of you went to the party? Sort of most of you. Okay. Anyone got a hangover? Well, just 3 or 4. Okay. So if you see them fall asleep, just nudge them. All right. Bang, big bang. Okay. So just to say what I'm going to cover, I'm going to be looking today at the Azure AD Application Proxy. Right, and it gets very confused and mixed up with the web application proxy. The web application proxy is the on-premise proxy for Azure AD and also for applications. This is a proxy in the cloud. What's it look like? It's a cloud service, and that's all you're allowed to know. Right, how it's implemented is a secret. The reason is it changes every now and again as to how it's actually implemented. So what I'm going to look at is, first of all, I want to just mention some of our DMZ challenges. So first question, how many of you have actually got a DMZ or a perimeter network? Okay, so that's probably about 3/4. And of those 3/4, how many of you are actually publishing on-premise applications through that DMZ? And that's probably just under a half. Okay, so I want to look at what we're faced with, challenges with the DMZ. And then I'm going to introduce the proxy itself, and then go through publishing applications using pre-authentication, however that works and what it is. And then we'll look at actually single sign-on and how we achieve single sign-on. And we're looking at how we achieve single sign-on with a Windows auth application on premises. And then we'll look at how we achieve single sign-on with a claims application as well. And there are a number of different ways and the different scenarios for approaching single sign-on and how we do that. And then in terms of just wrapping up, I'm going to be talking about managing claims-aware applications in that environment. But first of all, if we look at the DMZ challenge, number one, you're faced with hardware costs. So it costs money to implement it. And then the next one is maintaining security. And I put a particular emphasis on maintaining. Because when people design their DMZs or their perimeter networks, they actually probably put their thinking hats on and discuss it, and they come up with this great lockdown security. They implement it, and then they start to publish an application, or they want to do authentication to an application through it. And suddenly you think, yeah, maybe we need AD inside our DMZ. Should that be a DMZ AD forest, or should it be part of our main forest? Oh, let's put a domain joined machine in there. And suddenly your firewalls begin to look like Swiss cheeses with holes everywhere. All right? And so the key is maintaining. And I've worked with companies who have employed, I should say, they've outsourced their firewall rules. And, so that you get the quote for deploying this firewall and it's X pounds. And then you get the quote for changing rules and it's 2x pounds. So they go and change the rules themselves. So maintaining is a big problem. And then authenticating users at the edge. It would be very nice that actually before you can even get onto our network at all, not even get into the DMZ network, it would be nice if we checked out who you are. All right? And then so you've got to have a device at the edge which is capable of actually authenticating. And then if you manage to do that, how do you get single sign-on when they come through, do the authentication at the perimeter, and then come through to the application, achieving SSO there? Because you don't really want people to be faced with 2 authentication prompts. So that's a problem as well. And then when this, as I've already said, actually having a web server and authenticating to that, how do you do it? Do you deploy a database onto that web server, an identity store? Do you try and do it with your AD? Do you have a forest, DMZ, and so on? Okay. Problems a lot of you have already faced. So let's see what we've got with the Azure Application Proxy, or the Azure AD Application Proxy, to give it its official name. It's a cloud service. It runs in the cloud, and it's offered as part of Azure AD. Right? And to actually use it, you've either got to have a basic or you've got to have a premium Azure AD license. So it either has to be basic or premium license. We have, going to on-premise, we have a connector. And the connector is outbound connections only. Right? So nothing comes from the cloud, originating from the cloud, coming into your premises. So the connector only speaks outbound. Right? So you must be able to service those outbound network requirements. Right? And I'll come to what those requirements are. The connector gets deployed on-premise, and you can have multiple connectors. And now you can have connector groups, so you can group connectors together, and that's in preview at the moment. So we can do fault tolerance, we can do sort of rudimentary load balancing as well through the connectors. So it automatically balances traffic through those connectors. In terms of prerequisites, we need, as I say, we need basic or we need a premium license. And I've put a little link in there to where you see all the different versions of Azure AD. So you can go and have a look at that. You've got the free, but you can't get the actual proxy with the free. You've got to go premium, you've got to go basic. If you're new to all of Azure AD, you simply sign up for a free one, and then you can sign up for a free trial of premium. And then you can actually deploy the connector and try it out on premises and see if that's the route you want to go. In terms of the connector, it has to be installed on a server 2012 R2 or higher. So it will actually work. I've had it deployed on a 2016 server, so it's actually working on that. You can deploy it on Windows 8.1, but I mean, would you want to? But if you want to, you can. So if you're doing experimental and trials, just remember it has to be 8.1 or higher. And then you need to enable the internal firewall, your firewall on premises, to allow outbound connections from the connector. Right? And those outbound connectors will actually connect up into the service bus inside Azure, and that's how it communicates with the Azure the actual proxy up there, so it actually connects up to the service bus. There is a little application which is published by the App Proxy dev team, and I put a reference to it there. It's testport.cloudapp.net. Question is, will it be maintained in perpetuity? I asked the guy who actually designed the connector, and he said, yes, of course. But the guy who actually designed the connector has now moved on to a different team. At the moment, it's still working. It's actually very useful, and I'll just show it to you in action. It's a very quick check to see whether your connector is going to be able to get the ports it needs out through your firewall. How do we get the connector? We simply download it from the portal. So when you enable the functionality in the Azure portal, you can download it. And when you install it, it's a really simple install. You just run it, and you'll be prompted at some point, and it says, what's your AD tenant? So that your tenant is your Azure AD Active Directory, the name of it, and you simply log into that as an administrator, and then what it can do is it makes the connection, and now your connector is connected up to the cloud. And so it's a very, very simple install to do that. There is also a little troubleshooter that comes with it. The troubleshooter didn't used to exist. Now it exists. So I wonder whether the testport.cloudapp.net will disappear at some point. But for the moment, it's still there, and it's really useful. Those are your required outbound connections. I'm not going to talk through the list. It's quite a comprehensive list, but remember, it is the connector making the connection out. Nothing has to, in terms of incoming connections, there are no incoming connections. Once the connector is installed, it actually puts two services on the computer that's running the connector. One is the actual connector service itself, and one is a connector updater. So the connector can update itself from Azure when necessary. In terms of publishing applications, we publish them through the Azure portal, and currently we use the classic portal. I don't know how many of you have actually seen the Azure portal. There are two versions of it at the moment. The original portal and a brand new, really funky new portal, which is all written in HTML5, and it's amazing bit of HTML5. At the moment, the Active Directory, or the Azure Active Directory, is not in the new portal. Well, that's not completely true because it is in the new portal, but it's in private preview at the moment. At some point, it will move into the new portal, but for the moment, you manage it through the classic or the old portal. You must specify, when you set this up, you need a name. So you need a name for the proxy in the cloud. You need an internal URL of the application you're going to be publishing. You need to decide if you're going to use pre-authentication. And what pre-authentication does is it basically says, you ain't coming through the proxy until you've authenticated to me. And where do you authenticate? You authenticate with the Azure AD. Right? So if you want pre-authentication, you can have it, but then you've got to deal with the issues of single sign-on. And or you can publish without pre-authentication, in which case what will happen is this guy up here will just act as a proxy straight through to your on-premise, coming through the connector, so coming through the connector secure channel. So all users connecting through the proxy must be assigned a basic or a premium license. So even if you're not using pre-authentication, you still actually, in theory, need a basic or premium license. In fact, there's no license checking if you're not doing pre-auth. So you will be able to get through. So if you publish without pre-authentication, users will be able to get through and use it. But officially, you're breaking the Microsoft license agreement. So how many of you have ever broken the Microsoft license agreement? No one. Amazing. And so with that's what we need there. And then in terms of, we need to assign the user to the application as well. So to use pre-auth, we will need a license and we will need to be assigned to the application. And how do we assign a user to the application? We assign the user specifically to the application. So we say, John can use this app. We can assign a group that John belongs to, or we can use Azure AD dynamic groups as well. So there's lots of different ways of making that assignment. In terms of managing domain names, then what it will do is it will create you a default domain name. The name will be, we specify a name for our proxy object. It'll use that name dash tenant ID, so whatever your tenant ID is. So mine's XTS AD. So XTS AD.ms appproxy.net, and that's the default. And you can live with that. You can do an HTTPS connection to it. There's automatically a certificate deployed there. If you want to put your own domain name there, what you'll have to do, first of all, is load your own domain name up into the Azure AD. So what you basically do is register your domain name into Azure AD, and what Azure AD will want to do is verify that domain name. So you'll be prompted to actually put a text record in your DNS zone, right? And they will specify what that text record should be, what the TTL is, etc. You put that in your zone, and what Azure AD will do is it will check your zone for the existence of that text record, and if it exists, it will say, okay, if you can put that text record in your zone, you must own that zone. So I will accept the registration of the DNS name. Right? So once you've done that, you can then use your own DNS name with the proxy, and if you do that and you want to use HTTPS, you're going to have to load a certificate up there as well. Okay. What else was on there? That's it. And so if we look at pass-through, and the interesting is I saw this diagram turn up in somebody else's slide deck yesterday. I thought, oh, that looks familiar. That's one of mine. I've actually published, I did it for Microsoft. I wrote a very in-depth troubleshooting guide for the proxy. And I'll give you a link to that. It's about 86 pages in the end. And I've got all the different scenarios you can use the proxy in as well. And that's one of the diagrams out of that. Having worked out how best to draw this thing for the white paper, I decided to use it in my slide deck. So if you see them somewhere else, they've come out of my white paper. So what this is basically showing the internet, showing the proxy up in the cloud, it's a cloud service, showing the on-premise connector, and then showing the application. Okay, so what I want to do is take you through actually publishing an application, and I'm going to do it without pre-authentication. So a very classic use of doing something without pre-authentication is for publishing the certificate revocation list distribution points. All right, so if you are publishing using certificates and you've got CRLs in your certificates, as in you will need to make those available. So this is one way of doing it. The other thing it's actually very classically used for, it's actually used for the network device enrollment service for Intune as well. So let's actually go across, and I'm going to start on my Windows 8.1 machine, and let's just bring this down a second, and I'll just show you that I'm sitting on the London network. So let's take that back up full screen, and I've got a little thing which actually is called Windows Auth. It's got no authentication at all at the moment, and it's showing me I have an anonymous connection to this little application. So it's windowsauth.xtseminars.com, and it's using SSL. So let's actually go across now and move that up onto the internet. So I'm going to move that onto my internet. So I come down here and take that up full screen again. And let's try it again. And can't display the page. Reason being, of course, is I haven't published this, right? So what I want to do is I want to actually use the App Proxy in the cloud to do that. So I'm going to go across to my DC, wherever that guy is, and I'm connected up to the classic portal in Azure. It's one of these things, classic, old portal, whatever you like. It's the previous portal, whatever name you want to give to it. And it continuously says, check out the new portal. And you can't do AD through it at the moment unless you're on the private preview. I've got a number of Active Directories in the cloud. I'm actually using this one here, the XT Seminars Active Directory at the moment. And if I look over here, I've got a number of different bits and pieces, the dashboard, users, groups. So I've got users, and I'll just show you those very briefly. So some of these users are defined in the Azure Active Directory, so they were actually created in the database in the cloud. Some of them are coming from my local AD. So local Active Directory, and these, so Liz, Marge, Maria, Mary, they've all been synced up from my local AD into the cloud. And they've actually been synced up with the passwords as well. The passwords don't go up, but a hash, well, it's a double hash of the password goes up. And that way you can log on premise using the same username and password as you can log on in the cloud. All right, so that's. I'll talk a little bit more about synchronization in a moment. If I go to the configuration on here, I have a premium license on my AD here. And if I go down, and there's a lot of stuff which I'm not going to talk about because we're not talking about that. There's the application proxy. I have it enabled. And this is a very useful one, manage connectors. If you click on there, it will show you what connectors you've got deployed. So I have a connector which is running on SRv1. That's the cloud IP, and this thing is active. All right, so it's just a quick check to see if your connectors are active. And down here, also, you have the ability to manage connector groups. That's currently in preview. But what we're going to do now is publish an application. So I'm going to come up to the top of this lot. I'm going to go to Applications. And I'm going to go to Publish an Application. So we're going to go New. I'm going to Add. And there are a number of ways of publishing applications. I'm not going to talk about the first two ways at the moment, but what I want to do is publish an application that will be accessible from outside of my network. Okay, so this is a proxy application, and I'm going to give it a name, and I want to make sure I use the same names as so what I call it, not Windows, but Windows and Windows are pretty much the same thing. Windows auth, and my internal URL of this guy is https Windows auth. Oops, sorry. And we've published it, it's xtseminars.com. Sorry? Oh, yeah, okay. Actually, do you know what I'm going to do? I'm going to move my chair so I can actually face the keyboard rather than sitting sideways to it. Thank you very much. Authentication method, I'm not going to use any authentication method. So let's just check that, http windowsauth.xtseminars.com and Windows author name. Click OK on that. And while that's actually cooking, what I'm going to do, and I'm going to have we'll let that finish first. Users and groups. These are users and group assigned to the application. We don't even need to worry about that at the moment. So what it's done, it says enable the application proxy. That's done. It says establish connectivity with the network. That is actually the connector. I've already deployed it, and I've deployed it onto SRv1, which is this guy over here. How do I know it's there? Well, one of the things I could do is I could check the services to see that it's there. I've deployed this onto my web server. So if we come down and just check out services, and we're looking for the Microsoft AAD App Proxy connector and the AAD App Proxy connector updater service. And I just said I would show you this check port. And that actually just goes up and proves that I've got outbound connections on those ports. And you won't get a green arrow on any of those if it doesn't actually make the connection. So it's actually a very, very useful one to remember. So it's testport.cloudapps.net. Okay, if we go back to my DC at this point, so what I'm going to do now is go to configuration. So I can, what will happen actually, this will appear in my apps, so I can actually have a logo for it, but I'm not going to do that. What I'm going to do is I'm going to change this. And the reason I can change to these different domains is because I've already loaded the domains into the Azure Active Directory. So you literally go into the domain tab and you say, this is my domain. It will say, prove it, by putting this text record in. And once you've done that, that's all done. Okay, so that's done. It's using pass-through. I'm going to save that configuration. And remember, it's using HTTPS. So what I have to do is make sure that there is a certificate up there. And what I've actually got is going down here. I've actually already preloaded. So I've got a wildcard certificate, but you literally upload the certificate. Azure AD doesn't care about validating that certificate in any way, so it can be a certificate from your own certificate authority, and as long as you make sure that your clients know how to chain it to root, etc., everyone's happy. Azure doesn't need to know about your root. Now, because I've changed this across, I'm going to go to windowsauth.xtseminars.com. What I need to do is add a CNAME record. So let's just copy that, and I'm going to go across to my what I call my ISP. So this is my Internet Service Provider, DNS, and I'm going to go into xtseminars.com. I'm going to create a new CNAME record, and this is going to be Windows Auth. We'll pop in the redirect up to, or the fully qualified domain name, which will take me up into the cloud. So Windows Auth dash my tenant name .ms@proxy.net. And by the way, Microsoft actually up in the cloud use a wildcard on this. So if you're testing anything msappproxy.net will resolve to the same IP address or the same group of IP addresses. So there's a wildcard used. Okay, so that's done. So next job is to go back to here, and let's try this. And it fails, and what, of course, and the reason it fails is not yet. We've got, well, I tried it before, didn't I? And I'm hoping it's failing because I've still got cached. So we need to flush the DNS because I've gone to exactly the same domain name as in windowsauth.xtseminars.com, and it was previously negatively cached. So there we are, we're in, okay? And no pre-authentication, and I've come in as anonymous, okay? So we need to start moving on from there to the next step. So that was how easy it is to publish something up through the cloud. So let's go back to the slide deck. So my next job is adding pre-authentication. So there's our sitting up in the cloud is the proxy. How does it pre-authenticate? It only pre-authenticates in one way, against Azure AD. So we're going to actually pre-authenticate against Azure AD. So what I'm going to need is users up in the Azure AD that I'm going to actually pre-authenticate using those users. There's a number of different ways that we can manipulate how the actual authentication is done. But for the moment, just assume it's authenticated against Azure AD. All right? So that's what we need to do. How do we get our users up there? We could manually put them in there and set a username, password up in the cloud, or we can use the Azure AD Connect from on-premise, and it will take those users from our on-premise AD and synchronize them up into the cloud. And as I said earlier, we can synchronize a hash of their passwords as well. So the passwords are the same on-premise as they are in the cloud. The Azure AD Connect started off as a very simple synchronization service. It goes way beyond that now. And you can actually do write back from the cloud. So someone changes a password in the cloud, the password change can be written back to your on-premise AD. We can now do device registration in the cloud, and the device registration gets written back to your on-premise AD. So AD Connect, or Azure AD Connect, is getting more and more sophisticated. So I would highly recommend, if you've got to synchronize your users up there, deploying it is really simple. Okay, and so you then know that your users are up there. So there's a little picture of thing with various options that are available on the Azure AD Connect. So let's go and put pre-authentication on our environment. So let me see where I wanted to start on this. So I'm going to go across to my DC, and where's my DC gone? Over here. Okay, so this is my guy here. So my Windows Auth proxy, and if we come down here, I'm going to go pre-authentication method. I'm going to go Azure AD, and I'm going to save that. So we've now going to save that, and as soon as that's finished cooking, we can go and actually test it. Okay, so let's go back to my 8.1. Let's close that off, and now do Windows Auth. Oops, let's just, I'm probably still remembering a cookie or two, so let's just clear that out. That's better. Whew, that's a relief. Okay, so I've now been redirected to my Azure AD, which has got my corporate branding on it, so you can brand Azure AD to look like your AD. And I've just done a very simple branding on here, but if you want to get some more sophisticated, you can do. And I'm going to log in here at Maria at xtseminars.com and put in her. And you may have noticed that it flashed just after when I tabbed. What actually is happening? It's actually looking at the login name, and then it redirects based on that logon name to my corporate branded page or my tenant. So it's worked out who the tenant is from the name. So if I put in a name of a different tenant, it would actually switch to the other tenant. So I'm now signing in. Well, I'll look at the little icon again in a minute. I think the little icon, if I click on it, it'll give away my password. I think that's the icon you're thinking about. I'm not going to do that. It looks a little bit like the Windows Hello. But having mentioned Windows Hello, if you're familiar with it, it's a framework where you can do facial recognition. So it's biometrics on Windows 10. So you can do facial recognition, you can do gestures, or you can use a PIN to unlock a TPM. And if you came to my session yesterday, I was talking about the use of the TPM and the use of Passport, whereas Passport chucks away passwords and what we use is private-public key pairs. That all works with Azure AD. So if I enable Passport on a Windows 10 device, I never have to log on to Azure AD again, because as soon as I use my Windows Hello gesture or my Windows Hello facial recognition, I'm automatically logged into all my services in Azure AD. So that's pretty cool, but that relies on Windows 10. Right, corporate access cannot be accessed. You're not authorized to access this application. Oh, that's a bit mean. And it says, authorization failed. Make sure you assign the user with access to this application. Haha, didn't do that, did I? So we go back here, and what I need to do is I need to actually come over to users and groups on here, and this is Windows Auth users and group. I'm going to actually assign Maria to use this. So I'm actually going to go across to all users, click OK on that. And of course, the best way, as in best practice in AD, is to actually use groups to do this. But let's find Maria. So Maria Cruz, currently unassigned. I'm going to assign her. So she's now going to be assigned to use this app. There's one other thing which I left her assigned is under licenses. She will need a premium license or a basic license. And what I've got on here is I've got 100 licenses, which are, and Maria is assigned a license through here. I didn't use this as part of the demo because there can be a latency from actually assigning the license to it actually being, because when I'm logging on, I might not be on the same portal where the license was assigned. It's very rapid, the replication, but I don't even want to wait 3 or 4 minutes for it to happen. So I've already given her a license. I'm first prompted to say she's not authorized. If I was successful there, I would then be prompted again to say she wasn't licensed, but she is licensed. So let's go back over here, close that off, come back in again. And sorry, so where were you looking? Or was it after? So Andy asked the question. And so which bit were you looking at, Andy? So, okay. Oh, that. Oh, yeah, that will show you the password. Oh, look, my password's Andy Rocks. Yeah. Yeah, but it is very much like the facial recognition one. You're absolutely right. But it's very dangerous. So someone says to you, oh, what happens when you click on that? You give your password away. Okay, so now we're in. We've pre-authenticated. So we pre-authenticated to get on the network at all. We've had to authenticate as Maria. All right, now we come down through to our anonymous application. All right, how does the application authenticate? Well, however you decide it should authenticate. So let's get on to that bit. Oh, wrong. Where's it gone? There it is. Okay, so, and the other thing is conditional access. You can do conditional access, so I can actually set up things saying certain people need to use multi-factor authentication. If you're coming from a particular network, I can prevent people coming from a particular network and so on. So there's the conditional access is built into Azure AD, and on a sort of daily basis, it's getting more mature. So things change in this thing. But do remember, you can actually make conditional decisions about access in terms of where that person's coming from, and expect to see things like if the device is registered and so on in the future, if the device is authenticated. Okay, if we look at the flow, what's actually happened is the user has hit the proxy. So external URL, right? CNAMED up to the proxy. So we've hit the proxy. The proxy has looked to see if that user is authenticated. And it says, you're not authenticated. How would it know if that user was authenticated? I just hit the proxy. How would it know if I was authenticated? Sorry? If you have a token, yeah, but it's not going to be... It's going to be something else other than a token. You're absolutely on the right line. Think ordinary web apps. A cookie. What it's looking for is an edge access cookie, all right, which says you can get through the edge. If you haven't got one of them, it says, hey, you're not authenticated. Off you go and get authenticated. So we go up to Azure AD and says, please, can you authenticate this user? And actually, what it's using is OpenID Connect. All right, so it would have in the past used WS-Fed. It now uses OpenID, all right, which is one of the more modern protocols. It goes up there and it says, please authenticate me. And so now we authenticate the user. And what we do is we return an access code. And that access code goes all the way back to the user. Plus, we return a cookie which says this person is authenticated to Azure AD. Okay, so if we ever need to go back to Azure AD to authenticate again, we have a cookie to say we're already authenticated. So if we're ever sent back to re-authenticate, we don't have to because we present our cookie. All right? We get back a code, and this code is sent back to the browser. The code is useless. The code needs to be interpreted into an access token. Right? And so the code goes back to the browser, so even if somebody hooked in there and grabbed this code, they couldn't do anything with it. But what they can do is present it back to the proxy, and what the proxy will do is present that code back to Azure AD and say, hey, I'm the proxy. Azure AD will say, prove it. So the proxy will authenticate itself to Azure AD, and it says, okay, you've got a code, I know who you are, I'll translate the code into an access token. So we've now got an access token for the user. The proxy then says, okay, yeah, you are definitely who you say you are. What I'm going to do is reply to you, and I'm going to give you, this time, an edge access cookie. So now we come back to the proxy, and we go through the proxy, because we have this edge access cookie, and we end up at the application, and it's entirely up to the application what it does in terms of authentication. All right? So at the moment, we've got an anonymous application, haven't we? So we've got no authentication on it at all. So it just doesn't do anything more. But the key is there is nothing passed between the proxy and the application. All right? We know who the user is at the proxy, but by the time we get to the application, we know nothing about that user. All right? So the application does whatever it needs to do to the authentication and then renders the page. Whoops, so I want to do a demo on there where we're going to now turn over our application, and our application, remember, is currently anonymous. So I'm going to go over here. Let's just close that off. And we're going to go across to my server. And on my server, I'm going to come down to my Windows Auth application. So under my sites, and I'm going to go for authentication, and I'm going to turn off anonymous, so disable anonymous, and I'm going to turn on Windows Auth. Okay, so this is now a Windows Auth application. Right, let's go back to my Windows 8.1 box, and let's experience this. So there we are, Maria. So sign in as Maria. Oh, another prompt. Where's this prompt from? Connecting to, well, it looks a bit weird, but actually the prompt, this prompt is actually coming from my application. Okay, so let's try going in with domain credentials into the application. And see what happens. So that's whirling away. It's whirling away a bit longer than I expected it to. That's strange. I left something off. No. Okie dokie. All right, let's try something just slightly different. Oh no, it's done it. It's got there. Oh, actually, yeah, of course. We probably needed to wake up all the DLLs and everything else, seeing as we changed the authentication method. Notice what it says. It's using NTLM. All right. Never ever. It's NTLM v2, but never ever use NTLM unless you really, really have to, because you need to support something you can't support in any other way. All right? So that's the rule. You can do NTLM through the proxy. It may fail, though, because sometimes NTLM gets corrupted by going through multiple NATs and all sorts of things on the internet. So it's not 100% reliable anyway. All right? But it does work, but don't use it. All right? So this application says it uses NTLM. Let's move. Let's go down and move this guy onto the London network. So we're moving on to London, and let's try it again. So we're now sitting on the London network, and we're being prompted. This time we can see we're being prompted by the actual server itself. So we're going as example again, and we're going in as Maria. And okay, so we've actually come in using Kerberos in here. Okay, so it's actually using Windows Auth, and it's using Kerberos. And notice this down here. So the authentication asserted or authority in there. Actually, I'm thinking I missed a slide out here. Yeah, actually, I'm going to stop at that point. I'm just going to go back to the slides for a second, and then we'll carry on from that point. So what I've got is I've just enabled authentication, and I've got authentication working. If I go through my proxy connector, it's using NTLM, but if I go directly on my corporate network, it's using Kerberos, okay? And that's what we need to use. We need to use Kerberos. And basically, as a general rule of thumb troubleshooting technique, don't even bother trying to get your proxy connector working if it's not using Kerberos internally, all right? So what can we do? We can use anonymous, which we saw originally. You can use forms, you can use basic, you can use digest, you can use NTLM too, but don't, all right? Or you can use Kerberos using Kerberos constrained delegation. And that's what we want to fix up now, is getting the Kerberos constrained delegation component working. And with what we basically do is we come down to the connector, all right? And what the connector is going to do, it says, aha, I know who this user is. It's Maria at xtseminars.com. And what I'm going to do is I'm going to go off to the KDC and say, please, can I have a Kerberos token for Maria at xtseminars.com? And what the KDC will do is say, yes, okay, no problem. returns the token, and the token now gets injected into the HTTP header. All right, so we're now using Kerberos to the target. Now, for that to work, what we need to do is set up Kerberos constrained delegation with protocol transitioning. Because what's going to happen is, all we know is we know the name of the user. We know the UPN of the user. And we're asking for a Kerberos token based on that UPN. And that's what constrained delegation with protocol transitioning does. It allows you to transition from one protocol to another. Actually, what it allows the connector to do is actually request a Kerberos token just supplying the name of the user or the UPN of the user. Right? And if you think that sounds dangerous, perhaps it is. But perhaps you should look at what Kerberos constrained delegation is all about. That's how it works. Right? But we need to set it up. So on the connector's got to be domain joined, and we will need to establish Kerberos constrained delegation. So enabling KDC, what we need to do is in the Azure portal, we need to say use integrated Windows authentication internally. We can also use delegated logon identity. Okay, synchronizing users up into the Azure cloud. So on-premise AD users into the Azure cloud. Right? You log on the Azure cloud using a UPN. Right? You synchronize your on-premise UPN into the cloud. You've got a problem if your on-premise UPN is blah blah.local, because it's not unique in the cloud. It's got to be a unique name. So what used to happen is you had to update your on-premise UPN to something that is unique, i.e. an email. Right? However, that was really painful that you had to, if you wanted to synchronize into the Azure AD, you had to update your on-prem UPN. So what Azure AD allows, it allows, right, you to choose something else as the login attribute. And particularly, it's the your email. So you might be, your UPN on premises might be, john@xtseminars.local, but your email would be john@xtseminars.com. And what I can do is say, when you do the synchronization, take the email alias and synchronize that up into the Azure UPN. So how do I log into Azure? As john@xtseminars.com. How do I log in on premises? john@xtseminars.local. But nevertheless, it solves the problem. You don't have to update all your UPNs. Right. Now, up here, what we could have is the Azure UPN, which is john@xtseminars.com. And what we want to do is convert it to a Kerberos token based on the on-prem UPN. Right? What we need to do is actually remap it. So we've got this option here, which is delegated logon identity. We can say use the on-premises user principal name. So we might be logging in at john@xtseminars.com, but when it asks for the on-prem token from the KDC, it's saying, please, can I have a token to john@xtseminars.local? And what actually happens is when the synchronization process happens, you actually synchronize your mail address into your UPN, but you also take your on-premise UPN and just store it up in the Azure AD, so that when you need to do this remapping, it can be done. So we need to do that if we've got a mapping change. And then finally, on the server object that we're running the connector on, we need to do this delegated administration. And it's delegation with protocol transitioning. So it's constrained delegation with protocol transitioning. So what we can do now is pop back to the demo. So if you remember, we left the demo at, yes, it's all working. It's using Kerberos on premises. And if it doesn't, don't even go any further. All right? So, and it says here, application authority asserted identity. Right. Up to the portal. So I need my DC. And I'm up on the portal. I'm going to go over to my applications, and what I'm looking for is my Windows Auth app over here, which is the proxy. So we choose this guy. I'm going to go to configure. And I'm going to come down here, and what I'm looking for is the internal authentication method. I'm going to change that to integrated Windows. All right, so now it wants to use Kerberos constrained delegation. So I need to tell it what the internal SPN is. So it's HTTP whack, and it's Windows auth.xtseminars.com, and that's the internal SPN, and that's obviously registered on the account that is actually running the website. So that's done. And then if I wanted to, I've got this delegated logon identity. My user principal name is the same on premises as it is on the cloud, so I don't need to change that. You might wonder what these are for. Use part of the user principal name. And these are basically, it's not just about Microsoft houses. You could have a different implementation of Kerberos running in a Linux environment or something like that, and you need to do the delegation in a slightly different way. But if you're working on Windows, it will either be the user principal name that you sign on or the on-premise. So I'm going to just leave that as it is, and that, I think, is just about that. So I'm going to save that. I'm going to go over to my AD. Oh, sorry, I'm already on my AD. Stay on my AD. And let's take, yeah, I've got it here. So this is my Active Directory used in computers. I'm going to go to my computers, my server. I'm going to right-click on that. I'm going to go to Properties. And what I'm looking for here is delegation. And I'm going to say here, trust this computer for delegation, specific services only, and use any protocol. I now need to specify where we're delegating to. So SRV1, do a check name on that. And then what I'm looking for is the delegation on HTTP, which is here. And that completes that. So now I'm delegating. This is my connector doing the connection to the KDC and saying, please give me a Kerberos token to this resource. Okay to that. So back to my client. Remember, this is showing authentication authority asserted identity at the moment. We are inside our corporate network. Let's close that off. Let's go outside our corporate network. And I'm going to move over to my internet. And let's try again. So we're pre-authenticating. And there we are, using Kerberos, single sign-on, and notice here it says service asserted identity. So it's the connector that is now asserting the identity. Right? And that's Kerberos constrained delegation. A huge number of people are using it in this mode because it gives you a very simple way of authenticating to Windows Auth apps, right? But allowing them to be proxied out onto the internet. Oh, wrong place. So what I need to do is just switch back. So if we're authenticating to a claims-aware application, things are going to behave slightly differently. And what we've got here is our claims-aware app, and what our claims-aware app will be doing is redirecting the user to a security token service that it trusts. So here it says go off to a security token service. Now, in my example here, I've actually published my claims application. I have a claims app published, so I'm going to go now to claims, and we're pre-authenticating. So this is published out with pre-authentication. So I'm going to log in, signing in there. And there I'm being prompted. Now I'm being prompted by my ADFS server. All right, so I can log in here, Maria at xtseminars.com, And so what's happened is I've been prompted, and if I come down here, let's have it actually take that up. What we can see is who's asserting the identity. It's adfs.example.com. So pre-authenticated, hit the Claims app. It says my STS is ADFS. Right, so how do we deal with this? So here, if you've got two IDPs, there's no SSO, right? You're going to have to authenticate to both IDPs. So if you're going to be using ADFS, you need the ADFS proxy. So if you're coming from the internet, you cannot use Azure AD App Proxy as a proxy to ADFS. It doesn't work. It almost works, but it is not supported. So don't even try. I mean, I did manage to, when I was writing the white paper, I did manage to get it working, but it was a real kludge. All right? So don't even try it. It's not supported. It's not a scenario. If you want to, if you've got something outside and you want them to authenticate to ADFS, then you will have to deploy the ADFS proxy in a DMZ. All right? So that's one scenario. Now, how do we get SSO? So what we can do is we can use AD, Azure AD Federated SSO. And this is very typically used in the sort of Office 365 space, where rather than authenticating to the AD in Azure, what it says, I want you to go and authenticate to your on-premise AD. So what we do is we set up a trust relationship. So Azure AD trusts your on-premise ADFS server. So we hit the Azure AD, so pre-authentication, up we go to the Azure AD. The Azure AD says, I don't authenticate you, but I know who does, and I trust your on-premise AD, redirects you down to your on-premise AD. So you must have the web application proxy for Azure AD. So it redirects you down there, and you authenticate on-premises. All right? Having authenticated on-premises, you will have a cookie for the on-premises ADFS server. So now you hit the web application, and the web application says, I know what to do. I'll send you to my ADFS server to authenticate. Or if you go to the ADFS server, you present the cookie, which says you're already authenticated. And so you've got SSO. All right, so that works. The other way to approach it is you actually have a claimsware application. So rather than trusting your ADFS server, you set up a trust relationship with Azure AD. So you publish the application in Azure AD so it becomes, you remember the three options we had when we were publishing an application? One was accessible from outside the organization. Another one was actually saying that it's an application the organization's developing. And that way you can actually establish a trust from your on-premise claims-aware application into the Azure AD. So now what happens? Pre-authentication, Azure AD, authenticate, get a cookie. Come through the proxy, hit the on-premise claims-aware application, it sends you up to Azure AD to authenticate. But you already have a cookie, so you're automatically authenticated, and you're straight back down and into your on-premise. So you get single sign-on with your on-premise claims-aware app in that way. So two different ways of solving the same problem, but you have to choose which is the suitable one for you. So if you've already got federated SSO with Azure AD, then you can go down that route. But on the other hand, if you haven't got federated SSO with Azure AD, you can trust. And the advantage of this, you don't need any on-premises ADFS infrastructure. All right? So this way, you're running claimsware applications, no on-premise ADFS. So if you want to find out more, there's I've put a link to, there's a application proxy getting started. If you want a very detailed analysis of what's going on with the proxy, check out this white paper, which was a white paper I wrote for the product group. And it was very interesting experience because I started writing this thing, and as I was writing it, I was finding bugs. So I said, well, how do I write that about that in the white paper? They said, oh, don't worry, we'll fix it. So there was a lot of debugging that went on at the same time, but it was a very interesting experience, great team to work with, and that is sort of the definitive guide on how this thing works. But in this 1 hour, I hope I've given you some insight into what goes on under the hood with the actual proxy. I hope you found it useful. Sign up for a free trial of Azure AD, sign up for a free trial of Premium, and you can get started. And have a great rest of the day, and hopefully see you next year. And thanks for coming. Oh, and don't forget to use the correct colored card. Now, which one was it? Oh, I think it's that one. All right, thank you very much.